Alrighty, so second day of this fun. Starting out, just like we did yesterday, is the ordered pair a solution for this equation? So 0, 6. Remembering that first number in the ordered pair is the x, second is the y. So in other words, does 6 equal 0 plus 6? You betcha it does. 6 equals 6, so yes, it is a solution. Go ahead and head into class kick. I've got one there for you. Okay, is 4, 1 a solution of the opposite of x plus 3? So again, that 4, I'm going to switch colors here. There we go. It goes in for y. So 4 equals the opposite of 1 plus 3. So does 4 equal 2? No, it doesn't. So this is not a solution for this equation. There's others, but this is not it. Go ahead and continue for another example from me. So just like yesterday, we're looking for a solution using a table, an equation, and a graph. Ty is 3 years younger than B. Okay, so in other words, when Ty, we're going to say, okay, we're going to say B's age, that's going to be the BEA is going to be the X, that'll be the input. And we're going to say that Ty is going to be the Y, right? So what that looks like then, when B was 3, oopsie, where'd it go? There we go. When B was 3, Ty was born, right? So when B was 4, Ty was 1. When B was 5, Ty was 2. When B was 6, Ty was 3. Notice there's a 3-year difference there, right? So if we go to graph that, so we wanted to graph in an equation. Let's write the equation first. Ty, right, that's y, equals B, who's x, minus 3. That's what we're looking for. So graphing it, we're going to have 3, 0, starting down here. Then we're going to have 1, 4. Or 4, 1, rather. I'm supposed to set it backwards there. Be careful. 5, 2, and 6, 3. Making that lovely line. Whoopsie. Dagnabbit. There we go. Kind of lost track of it. Trying to hold it in place. Okay. Anyway, and then we get to play connect the dots. Where's my dog barking? She wants in. There you go. And I do recommend, by the way, using a ruler when you're drawing these lines. I didn't here. It's really tough to try to draw them on a screen, so I've done it some with a little bit of success, but not as much as I expect on paper. So go ahead and pause, head into class kick. There's one for you. All right, so hopefully you've worked that one. I have graph paper and all that in class kick for you. And you get to find out how much fun that is to try to draw right on the screen. So Gavin makes $8.50 for each lawn he mows. Now, so this one is, the input is lawns mowed, right? So that's the X. So we're going to make our table here. X is number of lawns, right? Number, there we go, lawns. And Y is dollars made. Okay? If you mow 0 lawns, you have no money. Plain and simple. However, I was moving things around there, I kind of lost track of what I was doing. Forgot I was recording, I guess. However, if you mow 1 lawn, you get $8.50. You mow 2 lawns, you get $17. Or Gavin does, not you, I guess. You mow 3 lawns, you get $25.50. And again, how am I doing that? Well, Y, the dollars you make, is $8.50 times X each lawn. And there you go. That's all there is to that one. Now we're going to graph it. And our graph of it will start out, and you can kind of see I've got the answer here in front of me as well. And I've got my table still out. When you graph it, on this one, I would certainly start out at 0, 0, right? No mowing, no money. Then we continue, and at 1 lawn, we make $8.50. So 1 lawn, and I'm going to quickly run out of space on this graph. You can see I should have done something with it like this one. Let me bring that one in and show you Should have done something more like this, where each one is 850 at 2, and so on and so forth. I should have some sort of scaling thing. So kind of learned my lesson there. Or have a way taller graph, right? That'd be okay too. But so there you go. Go ahead and continue for another example from me. Alrighty. So here we have another example. Use a table to draw a graph and answer the question. The table shows the height in inches of stacks of tires. Extend the pattern. What is the height of 7 tires? So I decided, by the way, to go ahead and learn my lesson from the last one and go ahead and go by 8s on this side here. You can go by 10s, go by whatever, but 8s kind of makes sense. So I didn't finish scratching out the rest of those, though, there. So there you go. So we're going to go ahead and do this, right? 1, 8. Okay, I'm going to switch colors for the fun of it. 1, 8. 2, 16. 3, 24. Notice again I relabeled on the side here. 4, 32. And that means 5, 40. And if we extend this thing, right, you can go 0, 0, 2 because 0 tires is going to make a stack of 0 inches. And just keep going and going and going. And what am I going to get? Well, I'm going to say that how many we want? A stack of 7 tires. So 7, goes up here, comes across to 56 inches. So there you go. That's how I got that one. 56 inches. Go ahead and pause, head into class kick. Your turn. Okay, I'm going to quick talk about this one before I even start. Use the table to draw a graph and answer the question. The table shows the length in centimeters of a scarf you are knitting. Suppose the pattern, that's fun, right? Suppose the pattern continues. How long is the scarf after 8 days? And I will say, again, my wife sits and knits, and she finds it very therapeutic. And I think it's cool because she makes fun stuff. So, but anyway, I went ahead before I even started, and I wrote an equation for this. Y equals 2x plus 10.5. Now, for our purposes this year, how did I write this so far this year, what we've learned? I kind of just played around with numbers till I got it. I thought about, what would this look like at 0, right? I counted backwards. Well, this is 18.5, 16.5, 14.5, 12.5. Each time going down by 2. So if I extended that with that logic down to 0, I'm going to switch to red here. Sorry about that. 0, I would get 10.5, right? So I thought, okay, well, how do I work my way back up? Well, if every time I double the x and add 10.5, because double 0 is still 0, right? Double 1 is 2, plus 10.5 is 12.5. Double 2 is 4, plus 10.5 is 14.5. So that's how I kind of found it. I played around with the numbers. That's honest. That's really all I did. So you really do have an equation here, but that's not the idea. We want to graph this. I don't like it when they ask us to graph the 0.5s. I think they're kind of being a pain here. But let me change the numbers along the side here, and we'll do it that way. Alrighty. So give us a whole new graph because I didn't like the other one at all. So let's go ahead and graph the points that we have, and let's get there, shall we? So we have the point 0. We decided 10.5. So right along 0, it's going to start here. About there, right? Not the halfway point between, but 10.5. Then we have the point 1, 12.5. Right about there. Then we have the point 2, 14.5. Okay, not all the way to 15 there. 15 would be halfway in between, right? And then we have the point 3, 16.5. And then the point 4, 18.5. And again, you don't want a straight edge here. And this one is kind of tough, I think, to graph it because of the 0.5s. Again, I'm not fond of them requiring that. So we go to 8, and we would say we go all the way up. And we're going to say, well, it's going to be 26.5, so right in this neighborhood. Let me get you a nicer graph for that. Hang on a sec. All right, so I went and grabbed a piece of software called Desmo, so you're going to use that in a few days. Really like this app. It can graph anything. So again, we go to 8. We follow that 8 all the way up, all the way up, all the way up. It looks like we cross here at, if we go over 25, 26.5. Yep. So that does work there. But again, the halves are kind of tough to graph. Not fond of them doing that here. And try to give you nicer ones on homework and stuff like that.